Okay, it is November 20. I know my glasses on, but I think it's November 28th. Thank you. We have our summative test on Pythagoras. Our first four questions, as always, are the trickier ones, the true-false, the ones I try and trip you up. And I'll tell you what, I got a lot of people making the first question wrong. It says the sum of the legs, and sum we already talked about is added together, right? That's the fancy word for added together, the sum. The sum of the legs of a right triangle equals the length of the hypotenuse. This is false. This is false because if we think of a right triangle and we think of the A and the B as the legs and the C, the sum of the legs does not equal the hypotenuse, does it? What is true? That if we attach squares to all of these sides, then the square, or A squared or B squared, these two numbers added together, or A squared, the square of A, and the square of B, does equal the square of C. So it's not A plus B equals C. That's false. It's A squared plus B squared equals C squared, or the area that squares attached to the legs equals the area of the square attached to the hypotenuse. A lot of people have that wrong. Question 2, a right triangle has legs that are 4.5 and 5.5 centimeters. The hypotenuse is 10. I got a lot of people on this one too. So they actually drew it, which was wonderful because the expectation would be you draw it. And if the legs are 4.5 and 5.5, I had so many people say 4.5 plus 5.5 equals 10, and therefore it's true. That's not right. Because those are the legs. Those are not the area the square is attached. So again, you would have to draw squares onto each of these. This one I know. This one I know is going to be, I don't know what number it is, but would you say that whatever that square, whatever 4.5 squared is, Carter, would you agree it's less than 25? Would you agree? Everybody in the room knows it's less than 25, correct? So we're going to say less than 25. I'm not even going to grab a calculator. I'm going to say less than 25. And would you say since 6 squared is 36, this has to be less than 36? Would you agree? Less than 36. I'm not even going to calculate. I'm just going to say these two things. Is it possible that a number that's less than 25 plus a number that's less than 36 will equal 100? It's impossible, isn't it? So therefore, it's false. If you actually wanted to work it out, you could actually do what 4.5 squared is and what 5.5 squared is. But we know that no matter what they work out to be, there's no way those two squares' areas will equal 100, and therefore it has to be false. Next question, the easiest question, because it's not actually even Pythagoras, it's from chapter 3 on squaring, and we only used exponents of 2. So the expectation would be you solve it. 16 plus 25 plus the square root of 25, which is 5, is greater than 100 minus 36 plus 1. Just a bedmass question, really. We have, when you work this out, I think it works out to be 46. This works out to be 64 plus 1, 65. Is that right? And since 46 is not greater than 65, we say false. It's not. 46 is smaller than or less than 65, and therefore it's not true. And our final true and false question says a square with a perimeter of 80. Oh my God, I got a lot of you with this one. Has an area of 400. So first thing you would do is what? Any question? First thing you want to do is what? Draw it. You're going to draw a square. And you're going to say the perimeter equals 80. What is the area equals 400. Is this true? Well, I can do it one of two ways. If I know the area, I could figure out the side length, right? So if you know the area is 400, what would the side length be? If the area is 400. Area of a square is 400, what's its side length? Anybody, just say it out loud. 20. So I can put it in. Now, if that length is 20 and it's a square, then all of these are 20, correct? And what would the perimeter be of that square? The perimeter is the distance around, so it would be 20 plus 20 plus 20 plus 20. It would also be 80, right? So therefore, this is a true statement. A square with a perimeter of 80 has to have side length of 20, and if the side length is 20, then its area is 400. Either way you do it, you have true as an answer. Okay, those are your 4 true and false. Question 5 is just a basic question, and if any questions were done poorly, it was number 5 as well. It says a right triangle has a square attached to the hypotenuse. I'm going to stop and just kind of draw it, just like this. Done. right? Without going any further, Jordan, you would agree that picture suits the first sentence. The area of the square, okay, the area of the square is 256. Do I put it here? Why? Because it's not the side length, is it? It's not the side length, it's the area of the square. So I'm going to put it right in there. The two legs are identical in length, so I'm going to put a little thing here and a thing there, and I'm going to draw squares here, right? If they're both the same size, leg, then they both have the same area, don't they? If they're both the same side length, they both have the same area. And if this plus this equals this, how will I calculate the area of this if I know the area of the hypotenuse square? I'm going to cut it in half, right? And I would get 128. So the first thing is to know that if this area is 256 and each of these are the same size, then their areas are 128 centimeters squared. That's step one. Now I know the area of the square. How do I get its side length, Bryn? If I know the area of a square, how do I get its side length? That's right, I square root. So the side length here will be the square root of 128, which if we know the square root of 121, we know it's a little bit more than 11. It's probably like 11.2 or 11.3. Grab that and square root it. It's 11.3. So therefore, this is 11.3 and this is 11.3. Am I done? No. I need the perimeter of the triangle. I know these two. What's this length? The square root of 256, which is it 16? Right? Almost done. The perimeter of the triangle will equal all three sides, so 11.3 plus 11.3 plus 16, which works out to be 38.6 centimeters in length. Now remember, perimeter is distance, and it's represented with centimeters. That's a unit of distance. Centimeters squared is a unit of area, meaning how many squares are inside the perimeter, really. So we have to make sure our units are correct. That's one of the hardest questions on the test, to be honest. That might have been the hardest question. Question 6 is the easiest question. It says a right triangle has a hypotenuse that's 10. A right triangle, hypotenuse of 10. That's the length of the hypotenuse, not the area. One of the legs is 6 centimeters in length, so I'm going to put it here. I'm going to put 6 centimeters. I'm going to put a square there. And it says, what is the length of the other leg? So by interpreting the words, I now have this. Since I know the length of the hypotenuse is 10, the area is 100. Since I know the length of the leg is 6, the area is 36 centimeters squared. And this plus this has to equal this. So by using subtraction, 100 take away 36 tells me this square's area has to be 64 centimeters square. And therefore, Abby, what's the side length? 8. So therefore, x equals the square root of 64, which equals 8 centimeters. That was probably the easiest question on the test, maybe. Question 7 actually was probably the easiest one now that I say it. A right triangle has sides that measure 4 and 5. Those are legs, so it's a leg and a leg. What is the length of the hypotenuse? If you did a squared plus b squared equals c squared, which is the Pythagorean theorem, then a is your 4, b is your 5, and c is your x. 16 plus 25 equals x squared. A lot of people made a mistake on 16 plus 25. It's 41. So what is the length of x? The length of x is exactly the square root of 41, which is approximately equal to, if I take my calculator and ask it, what is the square root of 41? 6.4 roughly. And I say it's approximately 6.4 centimeters. Question 8, it says a right triangle has squares attached to the legs of a triangle. Okay, I'll do that. A right triangle has squares attached to the legs. There's a leg. There's a square attached to the leg. There's my right triangle. One of the squares is 140 centimeters squared. I'll write it in the area. One of them is 116 centimeters squared. What is the length of the hypotenuse? There's my question. With the areas of the squares, Do I need to know this? Is it important? Is that leg length important? Do I need it to find the hypotenuse? No. If I draw a square here, do I know anything about that square? Yes, I do. What do I know that I haven't written in yet? I know that, yeah, there's an x side length, but what else do I know? That this area plus this area will equal this area, right? 116 and 140 is 256 centimeters squared, correct? I know that because I know Pythagoras. And once I know that, what is the length of the hypotenuse? The length of the hypotenuse is the square root of 256, which is exactly 16. Right? I square root the area to get the length. Okay? That one wasn't so bad. Question 9, what is the approximate length of the missing side of a right triangle if the two shorter sides have a length of 11 and 12? There was a student who I shall not name, but she's fairly smart, that said, Mr. McDonald, is the hypotenuse always the longest leg of a right triangle? And I said, yes, it is, because it is impossible not to be that. I know you did. So I'm going to put 11 and 12, those are the shorter sides, and x is here. Squares, area is 121. If the side length is 11, the area is 121. If the side length is 12, the area is 144. If these two areas added together become 165 or 265, that is the area of that square. What is the length of this? X is equal to the square root of 265, which is not the same thing as 256, is it, Madison? The square root of 265, oh, okay, never mind, is roughly 16.3. Did you make that mistake? Okay, good. Somebody put 256, and I said 256 and 265 is not the same number. Did you do that? Sorry. And then what is the Pythagorean triple? I think most of us just wrote down 3, 4, 5. It's just this. It's the basic side length ratio of 3, 4, and 5, and that's all it was. It just means that if you take these numbers, and if you multiply them by any number you want, so if I multiply it by 1.5, for example, I keep a proportionally larger triangle. That would be 4.5, 6, and 7.5. That would still follow Pythagoras. If I squared all those numbers, it would still work. So the basic idea of Pythagorean triple is the ratio of 3, 4, 5 makes any triangle. I only made it worth 1 point, and most of you got it right. Yeah, probably. Maybe I just wanted you to feel bad for a half a second and then feel good. Question 11 is the first of our 4 story problems that we've practiced ad nauseum. It's not the first time you've seen it. It's not the first time. It's like the 9th time. A 350 centimeter ladder. So I know from what I've been talking about before, this is the picture. We've done it enough that you know that's what we start with, correct? So from this, I can now write in my labels of things I know in this triangle. I should know 2 and not 1. So I know the length of the ladder is 350. That's the length of the ladder, not the area. The safety requirements say that the maximum distance from the wall is 50 and the closest the ladder can be is 25. So I'm actually going to need 2 pictures here. So the farthest away it can be is 50 centimeters, and the closest it can be is 25 centimeters. Now in both cases, I want to know how high up the wall, the maximum distance up the wall. So up the wall means this distance here. I don't know it. And just for fun, I'm going to call this one y because it makes sense now. X is going to be, actually I got them backwards. This should be, the closer it is to the wall, the higher it up it goes. The farther away that ladder is from the wall, the lower up it's going to go. So my X is going to be my lower distance, and my X is going to be my higher distance. If I solve it, I can redraw my triangle just to make it easier. X, 50, and 350. Attach my squares. X squared 2,500, because 50 times 50 is going to be that square's area. 350 times 350. Ooh, that's a tough one. I don't know if I can do that in my head. 350 times 350 equals 122,500. So I now know those two. How do I figure out the area of this square if I know these two? It will be this, this, take away this, will be this area. Agreed? So actually, I don't even need a calculator for that, do I? 122,500, take away 2,500. Everybody can do that, I think, right? 120,000, is that right? Is that the length? No, that's the area. There were some people that said the maximum length of ladder can go up the wall is 122,000 centimeters, which is a long way up for a 350 centimeter ladder. In order to calculate the distance, you need to square root that. The square root of that will be the distance. So grabbing a calculator, the square root of 120,000 is 346.4 centimeters. So x will equal 346.4 centimeters. That is going to be the shortest distance up the ladder it can go. Do this one again. 25, 350, and x squares. 25 squared is 625, is that right? Oh, I made a mistake. Did I? No, I didn't. I'm okay. 350 squared is still this 122,500. And this is going to be, this, take away this, is going to be this area here. So grab your calculator, 122,500. Take away the area of that other square. 121,875, 121,875 is the area. Sherzad, if I know the area of a square, how do I get its side length? Carter, I'm over here, buddy. What button do I press again? The square root button, that's right. Square root of this is 349.1. Therefore, in a sentence, the maximum distance up the wall it can go is 349.1 centimeters, if it's as close to the wall as it can get. If it's as far away from the wall it can get safely, the shortest up the wall it can get safely is 346.4. Okay. Question 12 confused people because there was no picture this time. You actually had to draw it, and some people didn't know which way north was. I'm just saying. North. So a ship starts off in the Cayman Islands. So here's the Cayman Islands. It looks like an island. It travels north at a rate of 50 kilometers an hour for 2.5 hours. Then it goes east at a slower rate of 30 kilometers an hour, and there were 4 people, not 1, not 2, not 3, but 4 people that thought it was for 5 hours. It's 5.5 hours, 5.5 hours. The question then says, after this time, how far is it from the Cayman Islands? That was the picture we practiced. So it's kind of a two-step thing. First, you have to know distances. If it's 50 kilometers an hour for 2.5 hours, and you multiply that out, you get 125 kilometers is the distance it traveled. That is the length of your leg, not your area. If it goes 30 kilometers an hour for 15, that is going to be 165 kilometers traveled. That is the length, not the area. If I redraw my triangle over here, and put 165 and 125, and put squares here, the area of that 165 squared will be 165 times 165, which is 27,225. And then 125 times 125, or 125 squared, is 15,625. The sum of those two, I'm going to add them together to get the other square, add that to the other one, I get 42,850. There were two people that said the following statement: Therefore, the ship is 42,850 kilometers from the Cayman Islands. For the record, the entire equator is the equator. If you traveled around the entire outside of the Earth, that is roughly the distance. So it is pretty long. But the square root of that is, in fact, your answer, which is 207 kilometers. Therefore, the boat is roughly 207 kilometers from the Cayman Islands. Question 13, equally as difficult a question as anyone has seen, because some people still are not quite sure what a diagonal is. I just like looking at you. But a diagonal is simply the corner-to-corner distance of something. So it says the diagonal of a rectangle. Okay, there's a rectangle. There's this diagonal. Okay, I started. Oh, the sides measure 10 and 12. Well, I can do that. 10 and 12. So far, so good. Is this longer, and I'm going to call it x, or is the diagonal of a square, okay, I can draw a square, with 11 centimeters, is this diagonal, which I'll call y, longer? Which one is longer, x or y? That's your starting thing. Well, we're going to see. So if you made your right triangle, you would have 12 here and 10 here. If you made your right triangle, they would be equal in measure. They'd be 11 and 11, wouldn't they? Because it's a square. If you calculate the area of this square, it would be 100. This square would be 144. And this square would be 244. And what would the length of x be exactly? Not approximately, but exactly. X would be exactly the square root of 244. Agreed? I don't know what it is, but it's a number. Sure. This one would be 121 and 121, and this area would be 242, the length of which would be the square root of 242. Tatum, we're just finishing the test. Now, some of you decided to actually calculate it, and when you did so and you rounded to one decimal place, they were the same length. But if you went to two decimal places, you were fine. But if you say you know the square root of 244 is bigger than the square root of 242 because it's a bigger number, you could then say the diagonal of the rectangle is a bigger number. Would you agree with that? Okay. And finally, your last question was Mr. Connell and Mr. McAvin. Soccer field. How many times did we practice this question? Once, my butt. We've done it more than once. Twice at least. 80 meters. 30 meters. Start. There's Mr. McAvin. There's Mr. Connell. Mr. McAvin, being the more athletic of the two, is going to run the entire soccer field. Mr. Connell, who's old and a cheat, ran here, and then when he started lagging behind, he cheated. He went across here and then back this way. How much shorter was Mr. Connell's distance? So, if I organize it first with McAvin, McAvin went 80 plus 30 plus 80 plus 30 because he went around the whole periphery, which was 220 meters. Okay? Mr. Connell, I'm going to call this X, by the way. Mr. Connell went 30 plus X plus 80 to arrive back here. So Connell went 30 plus 80 plus X. How do I get X? Find the hypotenuse. Put my squares on here. Grab a nice, let's go blue. 900, 6,400. This square, the hypotenuse, will be this plus this, which is 7,300. Did Mr. Connell run 7,300 meters across that diagonal? No, that's the area of the square. I got to square root that to figure out what X is. Square root it, 85.4. So therefore, it's 30 plus 80 plus 85.4. He did cheat. He's a massive cheater. 195.4 meters is what he ran, and I'm almost done. I now know how far Mr. McEvan ran. I now know how far Mr. Connell ran, and therefore, how much shorter of a race did Mr. Connell run will be 220. Mr. McEvan's take away the cheater's distance, which ends up being 24.6 meters less.